Okay, we're going to be working on problem 11 out of chapter 3. This is a cable problem. It also tends to be a concurrent force problem. So we have the point of concurrency right here. Downward acting force here, 50 kilonewtons. Two cables that are suspending this cable, we're going to call that tension B. This cable, which we're going to call tension A. Now we do have some geometry to deal with. We notice that that's a 135 off of the vertical. So what that gives us is 45 degrees off the horizontal. This is 180, or 100 minus 180 gives us 80 down here. Potentially that could be part of the biggest problem for some people, so pay attention to that. So now we're going to write sum of forces in X and sum of forces in Y, because this is a concurrent force problem again. We don't do moments, they don't come into play. So we're going to do this algebraically. Sum of forces in the X have to equal 0. So in the X I have minus tension A times its component cosine 45 plus tension B cosine 80 has to equal 0. And the 50 doesn't come into play because he has no vertical component or horizontal component. So we can resolve this to simplify it. Cosine 45 is 0.7071 tension A plus, we take the cosine of 80, and that gives us 0.1736 tension B. So we have one equation, two unknowns. What I'm going to do is write this in terms of A. So I'm going to bring this guy over. We're going to divide through by the 7071. So we're going to have tension A is minus 0.1736 tension B divided by a minus 0.7071 tells us that tension B is 0.2456. So essentially you're saying it's about 25% of tension A. So tension A, tension B. So we still only have one equation. So two unknowns still, so we're going to write the equation for Y. Sum of forces in Y have to equal 0. So in Y we have minus 50 plus tension A sine 45 plus tension B sine of 80, and by equilibrium that must equal 0. So cleaning that up, we're going to have 0.7071 tension A plus the sine of 80, which is 0.9848 tension B, bringing the 50 over, says that's all equal to 50 kilonewtons. So now recognizing that we have tension A is equal to this tension B, we can plug this guy into here, and we wind up with 0.7071 times 2, 4, 5, 6 tension B plus 0.9848 tension B is equal to 50. So now you'll be able to combine these two. So what you'll have, therefore, is tension B is going to be equal to 50 divided by those combined, which gives you 1.1585. Doing that division, you come out with 4.43 rather, 16 kilonewtons. Plugging that back into tension A. Tension A resolves to 10.6 kilonewtons. And there's your answers for tension A and tension B.